All right. All right, so here's our little introduction for OpenGL.
Yes. I don't get it.
Shit just got real.
Yes, you can do all of this in Max, and I will put this patch on the internet for you.
That's from Bad Boys 1 or 2.
That's 2.
Yeah,
Oh, really?
is it?
I was guessing 1.
I think it might be 1. I think it's Bad Boys 1. I'm not sure. It could be Bad Boys 2.
Oh man, just look at that. You know something just happened.
Or is about to happen. We're about to make OpenGL.
Yeah.
Somebody got
Yeah, so there's a it counts through a timer, and then when it gets to a certain timer, then it adds this message to presentation, causing it to show up. That's how it works. All right, let me zoom out and let's get started. Because shit just got real.
Like all of Bad Boys 1 and 2 with like cartoon bubble quotations.
Oh my god, that'd be awesome.
I don't know what
And we could add in like bang and pow and whale and splat.
All right.
Yeah, but it's working.
So, before we get started coding, let me do a roundup real quick and see, does anybody have any questions over the last couple classes? Anything you want me to look at again or show really quick? I don't want to spend too much time, but we can take another 10 minutes to show or to re-demonstrate or to answer some questions if anybody has any. If they don't, we can just move on.
We've all completely absorbed all of the information all semester.
It's done, it's there. It's like,
Good. I'm glad. Downloaded.
In our brains.
Awesome. All right, cool. So yeah, use the website. I'm updating things on that as quickly as I can. Some of the homework assignments will change, but it's not going to be adding too much more than what's there. I just am going to add some incremental steps to help keep you guys on track to completing the final project. Because what I think is most important in this class is in the final project, you get an opportunity to explore something that we wouldn't have covered otherwise. So I have a compulsory final project, which should just be an extension of the trajectory that we're already moving towards with our mixer. And you'll just be improving that and packaging that in an attractive way. And that should be pretty simple because you'll just be formatting and adding to what we've already done in class. And then you can use your creative energies towards your individual project. And that can be whatever you want within reason. You should email me today by the end of the day with what your ideas are. And I'll get back to you with guidance as to how to accomplish that, or whether I think we should modify that in some way. And then we'll have some individual, I think we should have at least one individual meeting outside of class with each of you at some point to kind of help you with your progress on your individual projects, so that I can help you with any tech problems you're having and help move you forward in that project. So that will be forthcoming. So yeah, let's talk about OpenGL. How many of you have heard about OpenGL? One, maybe two, a couple, probably. What context do you usually hear it in? Music?
No, use it.
Oh, use it, right, yeah. But okay, yeah. So yeah, I was expecting somebody to say gaming, because it's used a lot in video games. And that's kind of, we're leveraging kind of the hardware and software instruction sets that were mostly developed for video games. So OpenGL is kind of this common set of protocols and tools that you can use to talk to your graphics card for it to render 2D and 3D graphics. It's used to interact with the GPU on a graphics card as opposed to a CPU. And GPU graphical operations are much faster than CPU matrix-based operations. Does anybody have any idea why that might be? What the main difference in architecture between GPU and CPU is? So it has a lot to do with how basically it's cores. So a processor, a CPU processor nowadays will have 2 cores or 4 cores or maybe 8 cores, and that will allow it to do 8 simultaneous or 6 or 4 or how many cores you have simultaneous numerical operations at a time. And CPUs are designed for doing really complex math and shifting bytes around based on complex math operations and algorithms and stuff. And so consequently, they have a large memory for each of those cores to grab bits from and put bits into. And those operations tend to be changing constantly. And so you need this value from this operation that you just did 3 cycles ago, and you need to plug it into this value now and to complete the equation to figure out what your final output is. So it's constantly switching bits all over the place in this large memory cache. Now, on the other hand, a GPU, when you're working on pixels, you're doing a lot of the same operations on a large array of pixels in like the same area, because the way things normally line up is like most of your pixels, if you have a high resolution image, are going to be really close to the same in a particular area, right? These are so if you had a picture of it's like a jigsaw puzzle. If you look at the picture on the jigsaw puzzle, all the pieces that are in one area tend to look kind of the same, right? It's the same way with the raster graphic. Those pixels are very close to each other with only slight differences, and beyond that, just the operations and math that you have to do to those pixels to create the next video frame tend to be really similar on pixels that are in the same area. So what it does, and those operations are not particularly hard. Usually it's just changing of color slightly or changing of position slightly. You're not having to do complex math operations where you're grabbing values from 5 cycles ago and figuring out stuff that way. So the difference in architecture between the GPU and the CPU is that a GPU has a whole bunch of little cores that have very small memory, and a CPU has a couple of very powerful cores that have a lot of memory. And so with all these with a GPU that has 100 cores, you can do it up to 100 times faster than you could do it on a CPU. The same kind of calculations on a CPU, but you couldn't do the same kind of really complex calculations that you need to do to figure out really complex math equations and stuff like that. So they're different and they have their own strengths, but for graphics, GPU is hands down way faster, just because it was designed for it and because of those multi-threading and multi-core architecture.
Is that always the case now, or does it depend upon your graphics card?
Well, I mean, I guess it would depend on the power of your graphics card versus the power of your processor. Like I remember reading recently that Intel said that graphics companies were way inflating their numbers as to the speed difference between software CPU rendering and GPU rendering. And they said it wasn't 200 times faster, it's more like 14 or 15 times faster. But still 14 or 15 times faster.
So if you get a new computer with, like, say you bought a new Mac and you didn't upgrade the GPU or the graphics card or anything like that, it's still going to be faster.
Mm-hmm. For doing graphical stuff. Yeah. And, and all the API, the OpenGL API, how you talk to the graphics card, the GPU, is mostly dedicated to graphical applications. Although more and more they're leveraging graphics card capabilities for other things, like audio processing works really well because similar to pixels, most of your samples that are close to each other in an audio file are really close to each other, and if you're doing operations on them, they're going to have similar operations, just like pixels. So yeah, they've used GPU for audio. They've also used it for some math-based stuff like moving vertices on 3D models, stuff like that, where you used to have to do all that kind of vertex stuff outside on the CPU and then bring it back into the graphics. Now you can do it all in the graphics. And the graphics cards are now adding new hardware capabilities for decoding files. So newer graphics cards now can on the graphics card decode your H.264 files, which normally took a lot of processing power to decode. Now it takes that off of the processor and puts it on your graphics card. So it gives you more processor cycles for doing other things. So yeah, it's getting better every day. And so yeah. Does that answer your question?
Yeah.
Okay, cool. So yeah, in a nutshell, CPUs, fewer cores, lots of memory, complex math. GPUs, many cores, small amounts of memory, similar operations on similar pixels, on groups of pixels. All right, so let's look at this in Max now. Let's do some coding. So the main thing you need when you're working in OpenGL is you need a jit.gl.render. Jit.gl.render. And this is what actually sends all the GL commands to the graphics card and renders the frame. And so the way it renders is it takes a bang on the it takes a bang in this input, and that would render whatever is currently being stored in that render object, whatever drawing instructions you've sent to it. And then you'll also need an erase to erase the previous frame. So let's add those just manually for now, and then we'll put a metro on it later. Bang, and another message. Whoops. Erase. Send those into the GL render. We're going to need a window to be able to see this. Let's do a jit.p window. Now here's something that's important to know if you're going to work with OpenGL and these jit.p windows. These are mostly used for matrix operations where you plug a matrix right into this inlet. Matrix in, see? That does not work if you try to plug this GL render into that matrix in. That's not going to send video into it. What you need to do actually is go into the inspector for this and give it under name. It has to be the same context name as this GL render object, which I forgot to tell you about. Okay, sorry, going back, sorry. Let's talk about the main things you need. You need a window, you need a renderer, and you need a universe to render this in. A context is the official word, but you can think of it as a universe. So jit.gl.render, and then you give it its universe name, which let's just call it my universe. And so now anything that all the JIT-GL objects that will be sent, that send drawing instructions to the render, will have the same argument. The first argument will be the drawing context of where it's sending that, or what we call the universe. So all the other objects we add will have, jit.gl.sketch my universe, and then it sends it to this render object. You don't have to connect anything with lines. It's all based on this argument here. So now for this P window, if we want the renderer to send frames to this P window, we have to go down and under name here, right here where it's generated a unique name, this U69 whatever, or whatever yours says, some kind of U code. Put that to my universe. Now this will be receiving this will be receiving instructions to, this will receive frames from this JIT render, but we need to actually send it some drawing instructions if we want it to render something. So we can use an object called jit.gl.sketch to send commands to this render object, but we need to make sure it's in the same universe. So my universe. Now they're in the same universe. Open up the help file for JIT.gl sketch and click on drawing. And here's kind of right here, all this stuff. These are the kind of drawing commands that you can send to this object. This is kind of a simple GL rendering primitive object for doing really simple primitive stuff. You can do much more than this in the OpenGL universe, but we're going to start with this. So let's do some simple shapes, like let's do like a circle. Whoops. So all we do to send it a circle, we need to send it a message, circle, and then the radius of that circle. And most OpenGL objects work with a normalized scale. What a normalized scale means that the x positions values go from -1 to +1 instead of whatever the resolution of the screen is, because the resolution of the screen can change all the time. So, you know, if you were doing it on a bitmap basis, you would have to say, well, I want this at -5 pixels this way and up. You don't have to do that. You just say, I want it at -0.5, which would be halfway between the middle of the screen and the far edge of the screen. 0 would be right in the middle, and +1 would be at the edge. And then for the Y scale, it's actually backwards than you would think. 0 is up at the top. No, sorry, +1, -1 is up at the top, and 0 is in the middle, and then +1 is down at the bottom.
So top to bottom.
So top to bottom, exactly. Left to right, but top to bottom. All right. So if we want a circle that doesn't fill the whole thing, we could say circle 0.5, and that will do a circle with a radius of 0.5, which is like 1/4 of the screen. Whoops, we don't need to, I don't know why I did that. You don't need to actually connect this to anything. So just click this circle 0.5, and now click on the bang over here on the GL render, and you should get a circle. Now let's do a different shape. Let's do a square. I think it was called plane, actually. Plane.
Hey Jackson, what do we save this as?
Oh, sorry. Let's save this as file 10.1. OpenGL intro. All right, so send it a plane. 0.7, sure. 0.7. Try that. Click that and hit the bang again. What's going on there? Well, I think it has to do with the not erasing. Hit the erase and hit the bang, and now you'll see the way you should. And it's drawn this plane on top of the circle, so you can't see the circle anymore. But if we wanted to remove something that was there, you know, now if we did a, let's do a sphere. Whoops, that's an object. I need to do this as a message. 0.25. We might not be able to see it because it's in the middle of this square. Yeah, we can't see it because it's in the middle of the square. If you're getting this weird negative space thing, it's because you didn't erase. You need to erase first and then bang. So you erase the previous frame and then you bang a new frame. It's because this plane is still here and the circle is still here. So this sphere is in the middle of all those, and since they all have the same color and we don't have any lighting to show edges of anything, it's all just swallowed up. So if we want to get rid of what is in this drawing GL sketch object, we can send it the message reset. There we go.
Mine's not banned image for some reason.
Did you name your JIT-P window in your in inspector to be my universe?
Is it in the scripting name?
No, it's not in scripting name. It's in name.
Gotcha, sorry.
Yeah.
I'm having trouble erasing things.
Click erase first and then hit bang.
Should everything be erased or just?
Well, that's what we're talking about right now. So it's not erasing everything. It's redrawing what the JIT GL sketch is sending. So if we haven't reset what the JIT GL sketch is sending, it will send everything that we've sent it a drawing command to each frame. So when you erase it, so right now they're all layered on top of each other, and we can only see the biggest one, which was the plane 0.7. So hit the reset. Now hit the sphere. Now erase, and now bang, and now we see a sphere. But it looks like a circle. Why? Well, because there's no lighting, and lighting is how we kind of perceive three-dimensional objects on a two-dimensional plane, is through shading and contextual clues about that. So you have to tell it to do lighting. So you add that as a parameter. So let's add it to a parameter to this GL sketch my universe at lighting enable 1. And I think that will reset it automatically. So go ahead and click the sphere again, hit the erase and the bang, and now we have a lit sphere that looks like a sphere. Go ahead and right click on this inlet of JIT GL sketch and add an attribute UI for shape so you can play around with some other shapes. Oh wait, no, there isn't one for shape. I'm sorry. Never mind. I was thinking of a different object. That's a JIT GL grid shape. We'll come to that later. You're not getting any light. Did you say at lighting enable 1? Did you make sure there's no space in between the at and the lighting?
But there is a space after enable?
Yeah. Lighting underscore enable space 1.
Yeah, and then it's reset.
And then over here, did you erase and then bang on the JIT GL render?
Yeah, and everything.
Well, okay, so on your JIT GL sketch, hit the reset, then hit the sphere, then erase the frame, and then bang the frame. Yep. All right, let's see what you got over there. Was it drawing other things?
Yeah.
Okay, you have no space between my universe and the at lighting enable. So it thinks that your universe is called my universe at lighting enable.
Exactly.
Yeah.
Why does everything freak out when you try to move the view window?
So that is because, and that's one of the reasons why you don't often use a P window with GL. That is because the rendering frame hasn't been re-rendered. You've resized the window, but it's not re-rendering the thing until you erase and bang. So resize it, it looks all funky, hit the erase, and then hit the bang, and it should fix it. And if it still looks funky, try it again. Erase bang twice. Yeah, but don't worry, you probably would never use a P window on an actual show. That's kind of a glitchy thing.
That's crazy.
But
What?
you can move if you do it slow, you can just move the view window around the sphere.
What?
That's because it's not re-rendering it. All right, what? Oh, so you didn't say it light. You can watch your spaces. You need a space after lighting enable.
Oh my god. Texture on it.
All right. So we can also use pack or POC objects for these. Try this. Do a whoops, not a message. Get out of there. All right, new object, pack, the word plane, and then an F. And then we can take a float box in here. And now you could dynamically change the size of the box that you want to render. So if I wanted it to be a 0.4 erase, bang. Did that not work? Let me try reset. Oh, I know why I didn't bang it, and I used the pack. So I need to actually have a button over here to send the bang. Erase, bang, and now I get my plane of that size. Put my P window back to a normal. Okay, so this is really kind of annoying to keep having to erase and bang every time we want to see something. So we'll be adding that on a metro. Yeah.
One question real quick. How does the layer, how does it tell what's in front of what?
Okay, so that has to do with it has to do with its either 3D position, if depth is enabled, and there's a parameter to either enable or disable depth. So things closer to the camera will be on top. That's the first thing it will go by if depth is enabled. If depth is not enabled or things are at the same 3D position, you can specify which layer it is. And then you can put something on a higher layer that will be on top of something on a lower layer. And then if you don't specify and they're at the same 3D location, it's kind of a crapshoot.
So that's where we're at right now. Right, we're like at a crapshoot.
Well, there's only one thing being rendered right now.
Oh, sorry. But I rendered my plane, but my sphere stayed.
Oh, okay. So the JIT-GL sketch, that will keep track of everything, all the drawing commands that you've sent it. It will render everything that you've sent it until you reset. Okay. And that will be the layer order. I'm not sure. It's probably in it's in the order that you sent it. Okay. So newer things would be on top of older things, I would think. All right. So moving on, let's look at, so that primitives are great. Yeah. So but what about video? Let's see how we can use OpenGL to change your world when it comes to video. It's all about textures. So when we've been working with a matrix of video, we've been basically creating what's called a bitmap, where the computer has to figures out what the exact value and opacity of every pixel on the screen, of the entire screen, and that uses a lot, and it does it on the CPU, one mathematical operation at a time. Well, it depends on how many cores you have, but essentially one mathematical operation at a time. When we do something with textures, you're offloading that to the graphics GPU, which frees up your CPU to do other things. Also, the GPU is better at handling that, as I discussed earlier. Also, it's more optimized for figuring out how to apply that to a 3D object or a 2D object, how to transform that, to warp that, to whatever, to make it fit on a 2D object. And it's way faster at doing that than you could ever do with matrices. So we use textures, and you can texture something that's 3-dimensional. You can also texture something that's 2-dimensional. You can also texture something that's 2-dimensional that takes up the whole screen. So you think it's just a video, but it's actually a 3-dimensional plane that has a texture on it. And it's super fast. So let's look at how we can do that. We're going to make no, we're not. We're just going to add to this one. Over here, we're going to, so we don't have to keep erasing and banging, we're going to create a metro, QMetro. And let's use our handy hertz, 60 hertz. And we'll need a toggle to be able to turn that on. And so what did we have to do to create a frame? We had to erase and we had to bang. We also had to actually send drawing commands. Remember, because we went over here and we hit sphere and then we hit erase and then we hit bang. So we need a bang to send for our drawing commands. So let's use triggers. Trigger, we need a bang to send for our drawing commands. We need an erase to send to the renderer, and a bang to go to the renderer to actually send its render. Remember, because we'd hit erase and then we'd hit bang. So T, B, erase, B. Connect that, whoops. Connect that to the Q Metro.
So the hertz and Metro, is that HTZ or just HZ?
HZ.
Yeah.
All right. TB erase B. Yeah. Oh, so when I typed this in, it didn't actually matter because the what we were typing in ended up being a palindrome. But what you would actually have to type it in backwards. The thing you want to come first, you type last. I know, right? So here, look, let me show you. If I went T erase, or went T B erase test, like test was the last thing I typed, right? But if you go over here, this is output order 1. It's going to send test first, so that it lines up with this outlet. And because Max works right to left, that's why it is. It's stupid, I know. If I had to redesign over, I wouldn't do it that way, but they did. Okay, so, but in this case, it doesn't matter because the first thing is a bang and the last thing is a bang. So we just need to make sure we hook things up in the right order. So we're going to need to send this bang to our drawing commands, which in this case will be a movie player. So we'll send this to a send object for now, and let's just call it movie bangs. That'll be the first thing we do. Then the second thing we do is erase and a bang. We need to send that to a JIT-GL render. Let's make a new JIT-GL render. Let's call this JIT-GL render second context. And eventually we're gonna want to be able to blend these movies and stuff, and we actually have to tell the JIT-GL render that we want to enable blending. So we say @blend enable 1, right? True. And let's give it a orthogonal argument that makes that will ignore perspective angles of 3D, because we're working with 2-dimensional objects and we want those 2-dimensional objects to just fill up the screen and not worry about lens angle of cameras and so forth. So we can say at ortho 2, which is 2 is orthogonal projection where it normalizes the axes. Yeah, I think that's it. Or maybe it means that I'll look in a second. It either means that it normalizes the axes or that it maintains the aspect ratio, one of the two. All right, so we got those. And we send the erase and the bang into the JIT-GL render. And then we'll need a window to actually display this in. So we'll need a JIT dot window. We're not going to use a P window this time, and make sure it's in the same context or same universe. Second context. Great. And now we need a movie player to well, actually, here, first, before we do that, let's look at this. So we get this black frame here. And then turn on your Q Metro over here. And it turns gray. Why did it turn gray? Well, that has to do with what's called the erase color. So when you're erasing a frame in OpenGL, what does erasing mean? Erasing means that you're replacing all of the pixels in there with what? Black pixels? Doesn't have to be. It can be gray pixels, it could be yellow, it could be green pixels. You can change your erase color to whatever you want. And I think that's the reason why, because you can change it to whatever you want, that's why they chose the default to not be black, to kind of remind you of that. So the default erase color is like this 50% gray color. So if we want it to be black so that when nothing is rendered, we have a black screen, we just need to set an erase color on this render object. So let's specify an erase color. Blend enable ortho 2 at erase underscore color. And the way that works is it's 4 arguments, and they're all floats, and it's the percentage of red, green, blue, and then the alpha. And that's a little backwards than in matrix operations. In matrix, when we are dealing with 4 floating point color, it goes the opposite way. It goes alpha, red, green, blue. In OpenGL, it sticks alpha on the end. It's really annoying that they're different syntaxes, but that's the way it is. What did I say? Oh, erase color. We want it to be black. So we want 0 period red, 0 period green, 0 period blue, and 1 period alpha. We want it to be a fully opaque black pixel.
Is there a space between color and 0?
Yes, always. So you're at whatever the attribute is. Well, that's what the at is short for, is attribute. There will always be a space after the attribute and then the value for the attribute. And then if it's a multi-value attribute, there'll be a space in between each value. So now it's black again, and it's still turned on. Great. This is getting huge. You can always resize it, and I often will resize these so that all my ats line up, because then it's really easy to see what each things are. Sometimes you can't really do it all the way, but you get it close enough that you can easily see what's going on. It'll be really helpful. What else? Oh, okay, so now we got this. We're going to need to deal with this movie banks. We need to actually create our textures. So we'll need a jit.movie. And as of Max 7, you can output directly from the jit.movie, you can output a texture now. What you used to have to do in previous versions would be that this, and this by default will output a matrix and not a texture. And that's the way we've been using it up till now. It'll output that green matrix out the first outlet. And you would have to send that into a texture object to convert it into a texture. And that actually slowed down the computer a little bit because it required some computational power to move that matrix over into the texture object. But now it's all native built into the jit.movie, but you do have to enable texture output. So we say jit.movie at output underscore texture 1. Let me move this over. Oh, comment. Oh, there we go. That's what's going on. Okay. So at output texture 1, now it should be able to output a texture. We need to give the texture a name so that we can send it somewhere. so that we can specify to the object that's going to display the texture what texture it's going to display. So I believe that one's called at texture name. Yeah, there it is, texture name. And let's call it texture 01 underscore 01, no spaces in the name. And then just so that we're not annoying everybody, let's do at volume, at vol 0 period. Make sure you put the period for a float. Okay, and we'll need a read message to be able to choose a movie. And then we're also going to need the bangs over here from the Q Metro, so we just need to receive this movie bangs. Send that into the JIT movie. And now click the read and go over here to your shortcut, hopefully you have one, and pick a movie. I don't care which one it is. And now we just need an object to display this texture on. And there's a really easy object that's designed specifically for video and has a bunch of messages for video related things called jit.gl.videoplane. But we need to make sure it's in the same universe, right? Which was second context. And we have to tell it what texture to display. At texture, what did we call it? Texture 01 underscore 01, no spaces in the name. And there it is.
Sorry, can you zoom in a bit on that last object? I see.
So you should have video now on your screen. Yeah?
Sorry,
Not yet.
Not yet.
Vulnerable. Quick question. Where did you open? Where did you open?
Oh, in the movie, jit.movie up here, make sure you have a read message. And you bang that, and it should open a dialog box to select the movie. Okay, so you'll notice that this is looking weird, and it's not filling up the whole screen. Aspect ratio is weird. So I guess Ortho 2 is normalized axis and not preserve aspect ratio. But what we can do is we can actually specify a transform reset to maintain the aspect ratio. And actually, I'm kind of confusing myself now about the difference between orthogonal projection and transform reset. But for now, just do this, and I'll get back to you about what the difference is. All right, at transform reset, underscore reset 2. And now that fixes it. I'll get back to you as to what exactly the difference is between those and why. But just for now, if it looks weird, try playing around with transform reset 1, transform reset 2 until it looks right. And also your ortho 1 and ortho 2 and ortho 0. Those are kind of the things that will be messing around with camera angles and how things are rendered if your aspect ratio gets off or things just look weird. Okay, so now it looks right. It's taking up the full screen. Great. Is everybody's working?
It's telling me the jit.movie cannot bind to FBO.
Yeah, I got that too.
Jit.movie could not bind to FBO. And is anybody's working?
I don't see anything that should be working. I think I have some that truly wrong somewhere.
Oh, mine's working.
All right, let me take a look and see what you guys are doing. So, you know what? I think Windows, I don't know if the jit.movie
I had the video working before I put the transform in
A transform reset.
there. If I do that now.
Yeah.
Alright.
Try it now.
Something like that. We were supposed to make a short.
Where's your window? Oh, there it is.
Sorry.
Oh, I did make a shortcut.
Second context, a texture, texture
I was like,
one.
I know I did.
A texture, texture one. Wait. Oh, that's your video playing.
I know.
Where did you put transform reset?
Uh,
Oh, in there.
yeah.
Yeah. Okay. And
Oh, look, it's a b-ball.
just click on that. Yeah.
Yeah, my screen's wider. You have to see that.
I'll come right back here. Let me see.
You guys erase the screen?
Somebody else. Whose else isn't working?
I got it now.
Yeah, Jackson. I'm sure it's just a trigger on somewhere because it's just white. And I heard the video before I viewed my computer, which also means I did something with volume.
Have a race color. Well, your metro is not turned on.
Oh, it was
So that's
before
the
though, I
main thing.
promise.
And
There you go.
You had
this one. Race color is black.
it could be the video. Maybe it's
Where's your
the
GIF window?
video.
Right.
It is definitely black, white. Here we go. That's why.
There wasn't a space between that
Yeah.
and my volume. Oh, okay.
How did you get that video? Oh, you just selected one video.
Yeah, I just had to do that in the
You just had
okay.
an error. Make sure you got spaces. If it's not working, you might have a space in your thing wrong. Yours is working. Yours is working.
Wait.
Wait,
I
he
had
has
the white window, so what was the
So you've got the white window. That's because you missed the space between the texture name and the next argument.
if you want, you can look up the box.
Somehow.
I just can't figure out how to get it.
Usually that's what it means.
Oh, texture. Oh, I'm missing
Oh,
the
wait, was that the
underscore?
reset?
Yes.
Oh, yeah.
Transform
Right?
reset one.
Yes.
Maybe try that.
Now read the movie.
Oh, okay.
Because once you change an argument in it, it respawns that object.
Cool. Blading.
Okay. Texture name, texture.
Lost.
Did you read the movie since you made a change?
There's one called Dust that is in a barn. It's actually really pretty.
That did not work.
Here's your window. All right there.
You do. Just like mess it up.
No, that's one. Second universe. Second universe. You missed an E on your second universe. So you put it in a different universe. Your video plays in a parallel universe.
It's not a movie, that's why.
Somewhere your video's playing.
Somewhere.
It's a bag.
And now I got
Yes, yours just an aspect
Now I have
ratio.
a key.
So transform reset to.
One space, one letter.
Oh, did you ortho? Yeah, you ortho too. Did you
Do
change?
you ortho?
Do you ortho?
Do you ortho?
You gelin? You ortho?
Or you
Orthonian?
orthing?
Orwellian?
Or
Oh, you misspelled
I
transform
appreciate that
reset.
reference.
You said transform recessed.
Well, there's that.
Does that mean it's
All right.
recessing it?
Right there, transform reset needs a space before two. That's one thing that's wrong.
I did nothing. I did.
And texture. No, that's right. Texture one. All right, we'll reread this movie. Maybe you made a change and you didn't reread a movie. Okay.
You know what I hate?
So that's not it. Second contact, blend enable one, and ortho two, and erase a color.
Oh my god, when I was
There you
in
go.
San
You have
Francisco,
too many
they
zeros
were,
here.
like, on the, I forgot how awful
So you have 4 zeros. You should have only had 3 zeros.
Some dude was like
Because this is
blasting
red,
me
green,
with
blue, and
really bad
one.
rap over his cell phone and stuff.
Your
It was
pixel.
bad music,
You
but
sit
it
there,
sounded
There's another
really
thing
bad.
that's wrong.
He was like holding it up and jamming
Still don't
to
see
it.
anything
It's like,
though.
it's really
Oh,
bad. I wanted to
maybe
punch
this
him in the face.
Yeah, but what's worse is when somebody's Because like every once in a while, you're like, oh, listen to this song.
Yeah.
If they're
A
just
lot of-
sitting there,
a lot
like,
of, type
No, I know, I hate
You
that.
might not be able to find all your typos.
Sounds like you need to sound like you're ruining your stereo field. Like, I don't want to listen to the right side.
Can I give you some information? Your
Context.
stereo field is ruined.
You're
Ruined.
just, why are you listening to the left
Context.
side, sir? I don't understand.
Watch their like,
Is
I'm
that- are you
deaf in my
listening?
right ear.
Are
Don't
you
you feel like
listening
anything?
to those mono remasters? Because
Jit
that makes sense.
movie doesn't need to be.
Otherwise, I know I don't care for
Let's
that.
try
because you don't
rereading
listen
this
through
movie
it.
one more time.
Don't do that. No, they're right here.
What did you do wrong? You did something wrong. I'm just not finding what it is. I already found a couple of things, but it wasn't everything. Wondering. He must have spelled something wrong.
It was like sort of like just making up. I don't know. Something goes here. Something goes there.
Sing.
Stuff goes like this.
Oh, there it is. At output texture 1, you forgot a space. So you had a bunch of different typos. And all of those. I had to fix 3 things. They're still there. So just be really careful that you're copying the spaces and everything.
All right, guys. I think I solved all you guys' issues, and you all had the same issue, and that was missing spaces or misspelling things. So yeah, just careful. All right. Oh wait, I said I'd come back to you. Did you figure yours out yet?
No.
Oh shit. Okay.
All right. Output texture 1. It's probably some kind of name. That's what everyone else's has been is naming. Second context, texture 1. A texture out. Is that what's going on? Output texture. Oh, that's right.
The little gills.
So you're getting this cannot bind to FBO.
Little gill.
And that's on the jit.movie.
The little gills.
I'm really glad that she's out of
Texture
here.
name. Texture
Really, 'cause I said,
01.
Wait a minute. Too bad. Like, Lily, let's read the Kickstarter for our band.
I wonder if that's a Windows thing.
I feel like
Go into the jit.movie. I think that might be go into the help file for jit.movie.
Yeah.
So
I know that jit.movie works a little different in Mac than in Windows. Advanced. Yeah, click on the advanced tab. That's all QuickTime stuff, which we're not using.
Wasn't the video QuickTime though?
I guess
The videos that we're using?
I guess the summer.
Well, that doesn't matter. It's just decoding. I wonder. I just wonder if that's not a Windows thing.
Well, like the video was playing a second, like a
Okay,
minute
so
ago.
it's possible. Then it must be
It
something.
was something that we added that then all of a sudden it started popping up. I think it was. What was like the last thing we added?
Transform reset. Second.
You know what? It's alright.
Ortho to recreational. Raise colors 0, 1. That's right. Transform reset to. That's right. Did you reread a movie into your movie player since you made a change? Read a movie in there.
The little gills.
That doesn't
I'm gilling your
Does it matter if this is turned off or on when I read it?
No.
So that happened last.
Yeah, exactly. You're dead.
I don't want to do a nice little sucker. I don't mean exactly.
It helps it smell.
Try saving and reopening and see.
Yeah.
What kind of payment was it?
All right, let's move on. So yeah, we're texturing a video plane, but you don't necessarily have to texture a video plane. You can texture a 3D object also. Let's try that real quick. Let's do a jit.gl.plato, which is a way of generating platonic solids. You know what a platonic solid is?
Like like at that minute, like my video started working again. So I'm like, okay.
Oh,
I don't
thank
know what
God.
I did.
Good.
Okay.
Wow, really, we're gonna platonic solids.
Platonic solids. You know what those are? So they're developed by an ancient Greek mathematician, and what they are equilateral shapes that you can tessellate to create a three-dimensional object. So a tetrahedron is created out of 3 equilateral triangles. A cube is made out of 6 equilateral squares, so forth. There's only certain numbers of platonic solids that you get up to before things don't line up anymore, and it's not a true platonic solid. So let's see. It's just a way of generating primitive shapes, but we're going to use it to display some video on it as well. So we need to put it in the same universe. So second context, and let's set a shape. Let's start with a tetrahedron shape. Tetra, I think, is what the syntax calls for. At scale, let's set a scale so it's not gigantic. Scale, let's do something like 0.3, 0.3, 0.3. So that's the X, Y, and Z scale. At transform, reset, underscore reset. So what this is going to do is it's going to override the transform reset of the render and say, when you render this, render it into transform reset mode 1, which will maintain the aspect ratio of the platonic solid so that it doesn't stretch it out. We needed to stretch out the movie to make it have the right aspect ratio. I don't know. We'll come back to that. Again, I'm all confused about that, but just put transform reset 1. Depth enable. This time we want depth because we're working with a 3-dimensional object. So at depth enable 1, and remember, once it pops up in this attribute thing, you can click on it, and sometimes that's faster than writing. Depth enable 1. If we want to see it with the other things, we might have to deal with blending, so let's have a blend enable 1. Whoops, make sure you put a space in between your arguments. And let's give it the same texture as the video layer. At texture, what did we call that? Texture underscore 1, right? Yeah. Oh, yeah, you're right. It is 0, 1. Thank you, Trey.
You're welcome, Jack.
All right. And then to make sure that it's on top of everything, let's specify a layer at layer 1. And yeah, that's good enough. And there it is. And it looks kind of weird right now because it's at a weird angle. But we can actually manipulate this in 3D. Does yours not look like this?
Mine's just gray. Yeah, mine's just a gray shape.
Then you might have not specified your texture correctly.
At texture underscore 0, 1. Oh. Texer is not right.
Yeah. So if you want to be able to move things around, you can interact with objects on the screen if you give it a special object called a JIT-GL handle. JIT-GL handle. And connect that to the JIT-GL Play-Doh. Now you can move this around by dragging your mouse and see what actual shape it is. Oh, I know why it looks really weird. It's actually because it's getting clipped by the
Like in the same plane.
yeah, it's getting clipped by the video plane behind it. So we could actually move its position and put it in front of the video plane if we wanted to. We could click on this, go to position. You know, you right click on the first inlet and it'll give you a big old list of different options that you can change, parameters that you can change. change the Z thing to something above 0. And now it shouldn't clip. How did I get the position? You right click on the first inlet and then choose position out of this list right here.
Is it the third one you said?
Huh?
The first one?
The first inlet, yes. You right click on the first inlet.
Sorry, which number is what?
Which number is
Once
what?
you get the position 0, okay.
Oh yeah, X, Y, and Z. So if we want to put it in front of the video plane, change the Z value to something greater than 0. And now I'll put it in front of that, and it won't be clipped by that video plane. Cool? Got a lot to cover, so let's try to move on. Let's for now let's add an @enable 0 so that it turns it off, and let's just gives ourselves the option of turning it back on by putting an enable message here. Enable $1 for our wildcard, and then we can put a toggle up here to actually replace that $1 with a 1 or a 0, and then send that into the Play-Doh. So now if I click this, it'll turn it on. If I click it, it'll turn it off. But by default, it's off. And actually, we should attach that enable to the JIT handle also, so that way when it's off, because right now the handle is on, but the object is off, and we still get this stupid thing when it's off. So this way, if we connect it to it now, it should disable the handle and the object. All right, moving on. Let's do some mixing. Let me see. Mixing. Okay. So we have one movie player and one texture. If we're going to mix, we're going to need a second movie player and a second texture, but it all stays in the same universe. So we don't need another render object or anything. Let's copy this, duplicate all the JIT movie and all of its attachments, and change the output texture, the texture name here from texture 01 to texture 02. Let's see. And sorry, I'm just checking my notes. Okay, that's what I'm doing. Okay, great. So what we're going to do is we're going to change the opacity of the video plane that's holding each of these. We'll need a second video plane also. Where's my video plane? There it is. So this is the video plane for the first one. Let me move this 3D stuff out of the way. Get it over here. Here's my window. Let's put this over here. All right. So this is the video plane for channel A. This is the movie player for channel B. So let me rearrange this stuff to keep it from getting confusing. All right, so duplicate the video plane and make another one for texture B, or for texture 2. So now we have 2 video planes. And what we're going to want to do on these video planes is make sure they have no depth enabled, and that we also enable blending so that we can blend between them. So at blend enable, blend enable, you can click on it, 1, at depth enable, space 1. There we go, it's there. That should be all we need. Let me resize this so it's easier to see. There we go. And actually here, instead of doing that on that, I'm just going to duplicate this again and change the texture here from 1 to 2. And then resize. whatever. Okay. So what we can do is we can just set the color of this video plane, and the color will be the color is again 4 floats, and the 4th value is its opacity. So all we have to do is change its color from which by default is black. Actually, I think by default is the same as the erase color. It's like gray. I think the default color of objects is a 50% gray, and the default erase color is like a 75% gray, a darker gray. But what we can do is, by default, it's like this gray color, but we can change that opacity to something less than 1. And as we take its opacity down, that object will become more and more transparent, and consequently, any texture that's applied to that video plane will become more and more transparent. So that will reveal the other video plane beneath it, and essentially they're mixing it, this time with opacity. We can pack color. So let's do, let me give myself some more room here. We're going to want a color, a POC object, P-A-K, color, and 0, 0, 0, 0. And we can put some, let's make this bigger, and let's put some float boxes above this. Float, 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 float. And attach those to the inlets. Remember, you can line things up by doing Command Y. Okay, and now we can, let's attach this to a slider. Let's make the slider sideways. Just change its aspect ratio and it should automatically flip. And change this slider to have float output. Go into its inspector and click on float output and change the range to 1 period. So now it will output a number between 0 and 1. And attach that to this last float here. So now, and test it, make sure it's going from 0 to 1. Yeah, that looks right. And now attach this color to this video plane, texture 1 video plane. If you can't see the inspector window, it's just because you resized it. Like this is what you're having. So hover over at the side and you should see a resize icon, and then drag it over. Whoops. There, like that. Okay. Let's see here. We never did set up our second movie player. We have it here, but we never sent it. We never read a file into it. Make sure you read a file into your second movie player. And reread a file into your first movie player just to make sure, because we may have made a change in it. I don't remember. Yeah. And so right now it's not doing anything. I think probably because the second movie player is at full opacity and it's sitting on top of my first movie player because I instantiated it second. But that's all right. As soon as we finish this, it should turn invisible. So what we need to do now is flip this value around so that the other one gets the opposite. So grab all of this. We're going to need to send the same kind of parameters into the other JIT movie object. Duplicate all this. Send this color into this video plane, not movie, sorry, video plane. Make sure your pop color is into your video plane, not your movie player. And what we can do to flip this around pretty simply is just subtract 1 from it. Minus 1 period. Make sure you put the period in there to make a float. And then take the absolute value of that so that we don't get a negative number. ABS is the absolute value. And also that will by default want to be an int. So to force it into a float, we have to give it an argument of 0 period or some other float value.
So why are we doing this?
We're doing this so that this color gets the opposite of this number. So this one, when this one's 0, this one's 1. And when this one's 1, the other one's 0. And now we should have a mixer going. I don't. Let me check I probably changed something. Hold on.
I just went black.
Yeah, mine did too.
No.
Whoops. Well, poo. What's going on? Huh? Let me see here. Oh, I know why. I think these default values should be some form of 1 instead. It shouldn't be black. So instead of the default value being zeros, let's make the default values be 1. So change all these pot colors 0, 0, 0 to pot color 1 period 1 period 1 period 1 period. Yeah. And same over here. 1 period 1 period 1 period 1 period. And then move this. Yes, there we go. My movie player stopped actually moving, but at least I can see something.
I only have one.
So something isn't displaying on yours?
Yeah.
Looks like mine might be doing the same thing. Why?
Like I get the first one, but the other one's just black.
You have something to do with the -1 and the absolute 0?
No, I don't get. I'm getting the one on the left. Not getting the one on the right. Oh no, sorry. Other way around. Yeah. The slider's going opposite.
Yeah, I think I'm getting the same thing. I think mine's working the same way. So let me try to figure out what's wrong here.
So yeah, texture 2 is working, but texture 1's not.
Yeah, okay. Did we put a depth enable? Do we have a blend enable?
Yeah. But we just copied. Remember, the only thing we changed was the texture.
Yeah, depth enable, blend enable. Let's see here. Color 1 1 1 1. That's right. And this one's color 1 1 1. That's right. Second context. Texture 1, texture 2. Did that change? Did we change the texture when we copied something over? No, that's right. Texture 1, texture 2. It's weird. Yeah. I must have did something wrong, but I'm not seeing what it is. I guess let me try opening my other version and see if I can figure out what's wrong. So this is where I had pat color. It's all these. Second context, texture _1, blend enable 1, depth enable 0. Depth, did I say depth enable 0 or depth enable 1? No, I did. Depth enable 0.
Depth enable 1.
Oh, change those to depth enable 0. That's why.
There they are.
Great. Now, do you remember when we were matrix mixing, when you loaded the DV kite and DV ducks or rooster or chickens or whatever the MP4 chickens is, how slow your shit got? Try loading them now. Just try it. Go to the movie player, read DV kite and DV ducks into one and DV kite into the other one. And now look at your frame rate. Look at the difference in the frame rate. You may get a little glitchiness. That glitchiness, by the way, doesn't really happen once you go full screen. That has to do with it rendering other things in your just desktop. But if you go full screen, it will give it full graphical priority. But you'll see that this is like way smoother than it was when we tried to load these huge movies with the Matrix. That's the power of this graphics, of textures. And also, as of Mac 7, the way it handles textures, it uses a new architecture called AV Foundation, which is the same thing that Isadora 2.0 has taken advantage of, that has given you way bigger power in Isadora. It's just a lot better than trying to deal with Matrix graphics. All right, any questions on this? Yeah, did you set your slider to float output and change its range from 0 to 1?
How do I change it to float?
So in the inspector, go down here and there's a toggle that says float output. And then change the range to 1 period. All right, so we are now going to use this paradigm to update our 4-channel mixer, our model view controller 4-channel mixer. Actually, I wanted to show you one other thing before we do that. Let's look at, you can actually use the color of the video plane to do color correction of the content. So you can change these other color values, these other 3 boxes, and add more red or subtract red out of that image. Make sure you're all the way on one of the images, and then go ahead and try that. You're going to want to stick to values between -1 and +1. Oh, I'm on the wrong. There we go. So yeah, you can use this to do color correction. Simple color correction. And later we'll be going into doing effects with shaders for doing more complex color correction and other effects. All right, I have found, and it's kind of a bug, that sometimes your movies just stop playing. I don't think that happens if you're running things full screen. I think that's, again, just having to do with video memory of displaying your desktop and so forth. Let's add a way of going full screen on this window. Right, it's easiest just to steal from the help file on this one. Right click on the open the help file for JIT window and grab this code right here. And this does an escape full screen.
Sorry, which code?
This code, the P escape full screen from the JIT.window help file.
With the toggle.
Yeah, with the toggle and the full screen message. And now you can hit escape and enter full screen, and if you've cleared your errors and it's working right, it shouldn't not work again. Also, you'll notice in this full screen that you still have all this crap. If you want to get rid of that, you have to say on this JIT window, you have to say at FS menu bar 0 to get rid of the menu bar. And now when you full screen, it's just full screen.
FS menu bar
0.
0.
FS menu bar 0. All with me?
I still have a little bar at the bottom.
A little bar at the bottom. Oh, you like your pop-up thing? You're like your dock?
Oh, I hit a little red X.
There you go. I don't know what that was. Okay, so let's see. Let's start updating our model view controller mixer from the other day. So open up your what was it, 8.2 movie vals.
Jackson, sir, what does it say next to second context? What's that at? Something 0?
FS menu bar 0.
The toggle is going
It's short for file system menu bar.
bottom of the P thing.
What?
That toggle is going to the bottom of the P escape.
Yeah, this is a subpatcher for escape. You should have just copied this entire code from here. Just grab these, and then you send this from the full screen from the full screen message right into this JIT window. So using this color, into your text, into your video plane here, this is going to be important. So your homework for tonight, we're going to start by switching over, and it's not going to take long because we're just switching some very minor things in what we've done before. Switch it over for OpenGL, but we're not going to do the engine. It's up to you guys to figure out how you need to update your engine to now, instead of rendering movie players on a window, to instead render a OpenGL universe with these movie players in it. But let's look at 8.2 movie vals. Whatever it is. Yeah, 8.3 movie vals. There it is. All right. I don't even know if we need, there's nothing really GL about this. We're going to update this for effects, and we'll be adding some more faders and stuff, but I don't think I have time to do that today, so we don't really need to do anything with this except for just save it in our different directory, or our class 10 directory, or whatever directory you put your stuff in today. But make sure you save it as 10.3 movie vals, because eventually we'll be adding stuff to it that will be different than what's already here, than the 8.3 version. So actually, but we're going to call it 10.2 movie vals. 10.2 movie vals, all one word, no spaces. That way it's easier to instantiate. And make sure you're in your right directory, and save. And that's all we really need to do for that right now. So close that. And now let's create our controller. So open the controller from before, which was what, 8.3 controller, or was it interface? I can't remember what we called it. 8.3 interface.
Most likely, yeah.
Yeah. Great. Let's see. What do I want to keep and what do I want to take off of this? Well, actually, you can keep all this. We just need to move some things around. So let's give ourselves some more space over here. Move this auto pattern. Let's save this as also. and call this 10.2 interface. And make sure you're saving it in your class 10 directory or whatever you're saving stuff in, so you can find it. And let's see, is there anything we need to take out of this? No, what we just need to do is update these B patchers so that they conform to our new B patchers. So open up the inspector for that. And I guess actually we will have some time to go to add those effects sliders, because we're going to have some extra time.
Where did you put your auto pattern?
Huh? I just moved it over. It's still there. It's right here. It doesn't. It can be anywhere. So go down here and change the name patcher file here. And choose the new one that we just made. What was it? 10.2 movie vals. Yeah. Is that different? I guess mine might be different than yours slightly. That's all right. We'll come back and change that in a second. So yeah, do that on each of those. Or you can just duplicate it over, but you'll need to make sure that you're adding your arguments back in to make these be different. To each have unique sends and receives. So I'm going to duplicate this.
Sorry, what were the things that we changed on that first one again?
I changed what file it's loading to the patcher file to 10.2 movie vals. And then the other thing you're going to want to do is change the scripting name to something that makes sense. Before we used 8.3 movie vals. Let's do it 10.2 movie vals. It's kind of annoying, I know, but we're going to make this movie vals thing different. Trust me. And actually, to save time, I'm just going to do this again. Delete, duplicate, duplicate, duplicate. And then just make sure if you duplicated things from the first one, that you go in and change the argument here so that each one has its unique argument. So this is 1, the second one's going to be 2, third one's going to be 3, and so on.
Is there any reason that in the scripting name I wouldn't be able to type a period?
Yeah, I can't either.
Scripting name?
Yeah, weird. But you can take it from the 8.
Yeah. and
Wait,
one
did
of
I
the
do
lines.
something wrong? Oh, I know what I did. It's this argument. I was doing the wrong.
Oh, weird. It
4.
wouldn't let you paste the period in.
Yeah,
In what? In the
it's weird.
scripting name?
Yeah, you
Scripting name,
can't
you can't
type
put a period.
10.2. Oh.
Right? I can't even paste it in. It just like moves it.
But it automatically puts one in when you load the file. That's weird, but that's all right.
Just curious.
I don't even know that we need a scripting name.
Okay.
I mean, as long as it has a scripting name,
Yeah.
you're fine.
I just thought it was weird.
Because we don't care what these are called, because we're not really, when
Yeah.
we're doing the pattern storage, we're not usually dealing with specific values. We're usually storing and recalling all the values. And so as long as everything is unique, it should be fine, even if we don't know what everything's called.
So the only thing we were supposed to do so far was change the scripting name and change the.
You don't need to change the scripting name.
Okay. If
So-
we wanted.
Just change the arguments and the patcher file.
What were the arguments we were supposed to change?
So each one needs to have a unique argument, 1, 2, 3, and 4. 1, see down here at the very last thing, 2, 3, and 4.
Mine already had that.
Does automatically.
Does it automatically?
Well, I thought it was left over from since this used to be 8.3 or whatever it was, and they were already in there as 1, 2, 3, 4.
Yeah, it depends on what you did. If you duplicated your first one like I did to save some time, then it would have duplicated that argument on all of them, and that's why I had to go and make sure to change them. But if you went on each one and changed its patcher file individually, then you wouldn't have to, then it would still have that argument. All right, make sure that these are still patched into your UDP send. Okay, and great. Yeah. Okay. Let's go ahead and let's update the bpatcher file to add some new functions. We don't know what those are yet, but I'm going to add sliders and we'll use them later. So open up 10.2 movie vals. And what we're going to do is we're just going to add two banks of effects, and we're going to have 4 different sliders for each effect to change different parameters of that effect. So it doesn't matter what the effect is, we'll figure that out later. Slider, and make 4 of them. So take this and duplicate it. Once you get it lined up, if you just hit duplicate again, it will copy it and do the same alignment for the next one. So that's kind of a nice shortcut. It lines them all up for you like that. And then we're going to actually have a toggle so that we'll be able to eventually bypass this effect. And we're going to use the same convention that we used over here with our #1 and then an index symbol. So, whoops, we just want a message. Let's call this, so #1 so that it's unique, right? That's the patcher argument. Underscore, and then we'll call this fx1, and the other one will be fx2. So this is fx1, 1, right? So first parameter of the first effect, $1. And it's the $1 that's going to be replaced by this slider. And, okay, and then just duplicate this message. We'll make 4 of them. And do, this is fx1, 1. The second one's going to be fx1, 2, fx1, 3, fx1, 4, and then plug these in like so. And then we're also going to want an message $1, not $1 for our unique patcher argument, underscore fx1, let's just call it fx1-bypass $1. And remember, the $1 gets replaced by whatever you feed into it, and we're going to feed this toggle into it. And then send these into the output. The output of these messages. Make sure you're clicking on the right thing. When you're hovering over an outlet, it's green. If it's orange, it's an inlet. So if you have things really close to each other, look at the color. It used to be in Max 5 that you could only patch from an outlet to an inlet. You couldn't drag a line from an inlet to something else, but they changed that in Max 6. Yeah. See how these are connected?
Yeah, mine is just getting my effects bypass is just turning orange. I'm trying to figure out why. Oh, that's just a message.
It's a message. You had it as an object.
Yeah.
All right, so now that you got this, let's duplicate this as, actually move this message over because we're going to want some space to be able to not show these in our bpatcher. And move this auto patter over too. Somewhere else. Okay, now grab all of this stuff and we're going to duplicate it for the second bank of effects. And I'm going to put these, I'm actually going to want these to inhabit the same amount of space as the slider. So put them right underneath each other, but make sure you can move your messages around so that you don't get confused. Oh boy, I made a mess of it. There we go. All right, and then send these to the outlet also. I'm going to show you some really cool model view controller kind of stuff where you don't see these sliders until you want to, and then it like changes the view to show you these sliders. So now line these sliders up with the other big slider that you have over here, somewhere like kind of like this, so that these take kind of a similar amount of Y space. We can move this down, make the whole thing bigger. And let's see, I'm just going to move these down here so it's a little, I don't know. Okay. And make sure you've selected all of your lines here. You can option drag to select patch cords. And we want these to hide on lock. So we can do a Command K as the shortcut to hide on lock, or you can go to Object, hide on lock. And now when you lock it, we should see no cords anywhere. All right, we're going to want the ability to affect how this patcher is displayed. And that is done with an object called this patcher. This patcher. You can send messages like offset to this patcher, and it will be like scrolling your patcher over to the side. So what we're going to do is, by default, it's going to be the upper left-hand corner, and then we'll send it offset messages into the inlet that switch the thing over, that scrolls it over a little bit to reveal these other 4 sliders. Does that make sense? So we'll just need an inlet going into this patcher, and now we'll have the ability to hide and display these 8 sliders for effects. So save this. Make sure you're saving it as 10.2 movie vals. Save. And now it should update all of your B patchers automatically. And you should just see, you know, if you resized them to make them bigger, you might need to move this over or move this down. All right. It's 2:50. Those of you who have to go can go. We're going to go for another 10 minutes. The homework is going to be, whoops, that's why I didn't update. The homework is going to be figuring out how to redo the engine. Let's take a look at the old engine. How to redo the engine to be a rendering engine for GL to make these work, and also, or at least 2 channels to work, and then also do jitter tutorials 30 through 40. Jitter tutorials 30 through 40. Remember, to get to tutorials, you go to help, max documentation. If you're on something weird, click on the home button, the house button over here to go back to the main menu. And then scroll down, and here are jitter tutorials. We want to do jitters tutorials 30 through 40. So drawing 3D text through drawing OpenGL using GL Sketch, but not doing shaders. We'll save that for later. All right, let's look at, I'm not going to do this for you, but we'll get started and make sure you have kind of a handle of how to do this in the time that we have left. Let's open what was it? The engine, 8.3 engine. Okay, so this will be, you can copy this over into your new one. Let's go ahead and do that now. Let's say save as, and change this to be 10, class 10, and we're gonna call this 8.2, sorry, 10.2 engine. All right, but you're gonna have to change this because this is how we're doing video right here. We have our movie players here, so you'll need to go into these movie players and change these movies to have the same parameters as the movie player we did in our thing today, where you set them up for texture output at texture at at output texture 1, at texture name, and then give it a unique name. So texture 01, texture 02, 3, 4, so on, right? You don't need this unique one. You can take that out if you want. But you'll want to do jit.movie at output texture 1 at texture name texture underscore, all one word, no spaces, remember, 01. So this will be for the first one. The second one will be 02, so forth. Eventually, we'll change this route. For right now, we're not doing any effects, so all these routes will be the same. We are probably going to change how we're dealing with this multiplication section here, but as far as the rate and the file name, all that is still getting sent to the same jit.movie object, so that doesn't need to change. But you'll need to change each one of these pmovie playbacks, remember, because they're a sub-patcher, not an external patcher, so they don't, if you make a change in this one, it doesn't conform to this one, right? So you'll need to go in and change this one to be unique, and so forth. And then you won't have a jit.expression over here, and these won't be sending matrices. You won't even need this. This will be like here. This will be outputting its texture to. It'll be outputting its texture to a named texture, and then you're picking up your texture in the video plane. So instead of having this JIT expression that's mixing all of those values numerically on a matrix basis, instead you'll have a bunch of video planes over here. And the multiplications will get routed to their opacity, right? So you'll have jit.gl.video plane, and in the same context, whatever you name your context, that's another thing. You're going to have a renderer. So we'll call this, I don't know, whatever you want to call it, 4-channel mixer. Make sure you know spaces in your universe context name. At blend enable 1, otherwise it won't blend. At depth enable, because we're just doing with 2-dimensional objects in a mixer, depth enable 0. And then at texture 0, texture 01, right? Is that what we called the first one, I think? Underscore 01. So this is one of the 4 video planes you're going to need. You'll need 1 video plane for every video layer that you're mixing. And what you'll do is the multiplication that's being received will just get routed to our same, if just grab this stuff from over here, this color thing. Grab all this, bring it over. Paste it over here. And then the multiplication just goes into that, the opacity for that layer, right? And so you'll have 4 of these video planes. This is the first one's going to be coming out of this, the second one, third, and fourth one, going down to here. And then you just need to figure out, you'll need, so this won't be here. That won't be there. That won't be there. You're gonna need a JIT GL render. Make sure you give it the same universe. 4chan force what CH mixer. At blend enable 1 at erase color so that it's black 0 0 0 1, remember, and ortho 2. And I get back to you, I swear, about the difference between ortho and transform reset 2. And there you go. And it's now 3 o'clock, so you guys are all free. And so your job is to figure out how to make this render work. Remember, you're going to need a metro with bangs and erases. And you're going to need 4 of these video planes. And to get them to work with your B-patcher over here. That's your homework. Along with, I know, I got to give you guys real homework sometime. You can't just always turn in what we did in class. So that's your homework along with the tutorials, which is just do them on your own. But trust me, if you don't do them, you're going to be hurting later. And also today, please, by the end of the day, please email me with what your final project ideas are. And I'll get back to you in the next couple of days with some advice and direction. Yes?
So just reminders, like what are the things that our final project needs to include? Like you mentioned, like
yeah, it's all on the website. Let's look at that real quick.
Like for the mixer, does that be a video mixer?
Yes, certainly. 4-channel mixing, movie, pictures, graphics, etc., and live sources. Actually, I'm going to change that. We're not going to have to do live sources. If you want to do live sources, that's great. You'll get extra credit. Because we never got a chance to really work with live camera stuff in class. An effects stack, which we'll be going over in the coming weeks on how to build that. Model view controller, which we've already been working with, but I'm not going to be too harsh on you on that. I just want things to be really clean and as modular as possible. No patch cords going everywhere. Use a lot of sends and receives, that kind of thing. And then you definitely want a pattern storage system, a queuing system, and OpenGL everything. Yeah. All right? Yeah.
So, a couple things.
Yeah.
The first thing is I had most of this